In this question, they're asking us to calculate the indefinite integral of x e to the x with respect to x. So one of the first questions you usually ask yourself when facing a question of integration is, what method should we choose to attempt this question? And one might think that perhaps integration by parts is a good one to try here, just because you have a function multiplying another function. Of course, these types of situations are not always good for integration by parts, so we have to think a little bit more deeply about this. So one way to think about whether or not a question is suitable for integration by parts is to look at the integral that you have and realize the integration by parts formula will allow you to take one of them, a derivative of one of the functions, as long as you integrate the other. So if we look at this and we think about it, if we differentiate x and integrate e to the x, we can integrate e to the x, it just stays the same. If we differentiate x, it just becomes 1. So the new integral we'll have to do will be much, much easier because this x will have turned into a 1. So with that in mind, this seems like a really good idea to try this by integration by parts. So we're going to go ahead and do that. We have the integral that they gave us, which is x e to the x dx. Is equal to. Now what we have to do is decide what is our u and what is our dv by dx. So what we're going to do is we're going to assume that this is u, this is our choice, and the reason we chose this again for u is because the resulting integral at the end of this will have the derivative of u in it. So the derivative of u is just 1, so that'll actually make things easier if we choose this to be u. Of course that means that we'll have to take this as dv by dx. So let's go ahead and do that. If we take u and dv by dx to be this, we'll go over here and we'll just make our little chart. So we have u is equal to x, which means, we'll just fill this in, v is this, dv by dx is this. We chose this to be e to the x, and another part we'll need is du by dx. So we chose u to be x, so du by dx is just 1. We chose dv by dx to be e to the x, which means if we anti-differentiate e to the x, we get e to the x again. So now we go with the integration by parts formula, which is u times v, so x e to the x e to the x, minus the integral of v, which is e to the x, times du by dx, which is just 1, and of course dx. So now we see the actual benefit of doing integration by parts in this situation is that rather than do an integration like x e to the x, we've managed to convert it into a single integration of something that is much easier, because we've transferred, essentially we've taken the derivative of x, which just became 1, and we've replaced it by an antiderivative of e to the x, which again is just e to the x. So rather than doing a complicated integration like this, we can now do a much simpler integration like this. Of course, we know what this is. The antiderivative of e to the x is just e to the x, so this becomes x e to the x minus e to the x, because that's that antiderivative. And of course, because it's an indefinite integral, we put c.